Hello, welcome to Einstein's Mechanics. In today's episode, we are going to solve some objective questions under stress and strain, and I hope this is going to be much helpful. So these are our questions. Question 1. The dimension of strain is given us. So we have some dimensions given from A to D. D says dimensionless. So the dimension of strain, the answer is D. It is dimensionless because strain is giving us the elongation produced per unit length, which is going to be either in millimeters to the length millimeters, and it will cancel out. So strain is dimensionless. Number 2, what is tensile strain? So what is strain? Just as I wrote the formula here, we have from the options the ratio of change in length to the original length. Yes, so tensile strain is the ratio of change in length over the original length. So the answer is A. Are we okay? It is A. Alright, so number 3 says find the strain of a brass rod of length 250 mm which is subjected to a tensile load of 50 kilonewton when the extension of the rod is 0.3 mm. So with this we are to find the strain. The same thing, strain is change in length over the original length or the deformation produced on the length, and here we are seeing that there was an extension of 0.3 mm and the original length of the rod is 250 mm. So dimensionless, it will cancel out, and when you punch this you are going to get 0.0012. So the answer is B. Are we okay? Number 4, find the elongation of a steel rod of 100 mm length when it is subjected to a tensile strain of 0.05. Are we okay? So this means the strain is going to be now change in length or the elongation over the original length. And here we are to find the elongation, which is change in length, and that is going to be the strain produced, which is 0.005 multiplying the original length, which is 100 mm, and this is going to give us an answer of what? 0.5 mm. Are we okay? So meaning the answer is what? C, 0.5 mm. Number 5, a tensile test was conducted on a mouse steel bar. The diameter of the gauge length of bar was 3 centimeters and 20 centimeters respectively. So the diameter is given and the gauge length is given. The extension was given as this. What is the value of the strain? So we are interested in finding the strain. So here we have the same formula. Strain is going to be equal to the change over the length. So there was an extension of 0.21 mm and the original length, this is the diameter was 3 and the gauge length was 20. So 22 centimeter, that is going to be what? 200, right? So that is going to be 200 mm over here, and when you punch this you are going to get your answer to be 0.00105. all right, now from this it says strain is a fundamental behavior of a material. Strain does not have a unit. So which of the statements are we going to choose? So A says both I and I they are true, and I is the correct explanation of I. B says both of them are true, but the II is not the correct explanation of I, and both of them are false from C and D. So the correct answer is B. Both the statement I and the statement II, they are true. So here say they are true, but strain does not have a unit, does not explain the fundamental behavior of the material. Are we okay? All right. Now, number 7, a tensile test was conducted on a steel bar. The gauge length of the bar was 10 and the extension was 2 mm. What is the percentage elongation? So here, if you want percentage elongation, we have it as the percentage elongation. Let me say E is going to be the change in length over the original length multiplying 100. So here we are going to say the change in length, the extension was 2 mm, right? So 2 mm, let's write 2 on, this is 100 mm or 10 cm. So that's going to be 100. This is mm. I'm converting the length to mm or by 100. So this can cancel, and that is going to give us what? 2%. Therefore, the percentage elongation is what? 2%. All right. 8. The lateral strain is C. The strain at right angle to the direction of the applied load, which is C. So when I have a bar and it is trying to, this is the axial strain in this direction, and if it is trying to go this way, are you okay? This part will be the lateral strain, and you can see that the lateral strain is perpendicular on the surface. It's at right angle to the surface of what? The applied load. All right. Number 10 or 9, the unit of force in SI unit is, yes, so force is measured in what? Newton. So that is B. Which of the following is not the unit of distance? So milestone is not a unit of what? Distance. Alright, so number 11, a solid cube is subjected to equal normal forces on its surface. The volumetric strain will be x times the linear strain in any of the three axes when x is, so here when x is 1. Are we okay? So the strain in all the direction is going to be 1 multiplying the normal force. So it is equal to when x is 1. Number 12. A rod 20 cm long is subjected to an axial pull which elongates by that. Calculate the amount of strain. So the strain is going to be, we have elongation of, that is 2 mm, and we have the rod length, that is going to be 2000 mm, right? And this is going to give us 0.001. So that is A part. You can use the formula. So here, some structural members subjected to a long time sustained loads deform progressively with time, especially at elevated temperatures, which is what is such a phenomenon called. So when a member is subjected to a long sustained load and it deforms progressively with time, especially at high temperatures or elevated temperatures, what's that phenomenon called? It is called creep. So the material will be what? Under creeping. So that is B. 14. Find the strain of a brass rod of length that which is subjected to a tensile load of that with an extension of that. So here the strain is also going to, so this is stress. Strain is going to be deformation 0.1 mm on 100 length, and that is going to give us 0.001. 1. 15. The property by which a body returns to its original shape after removal of the force is called, that is, elasticity, meaning the body is elastic. If you remove the force, it returns to its normal position. The property of a material by which it can be beaten or rolled into thin plates is called, that is, malleability. 17. Which law is also called the elasticity law? That is the Hooke's law. The Hooke's law is also called the elasticity law. Number 18. The materials which have the same elastic properties in all directions are called, so a material with same elastic properties in all directions, we call it isotropic material. So that is A. A member which does not regain its original shape after removal of the load producing deformation is called, that is, plastic. If it regains its original position, it is elastic. If it does not, it is plastic. Alright, so 20. The body will regain its previous shape and size only when the deformation caused by the external force is within a certain limit. And what limit is that? We are saying some bodies regain their position, they are called elastic. Some do not regain their position, they are called plastic. So in what limit will it gain its original position? And it's supposed to be in the elastic limit because we say it is elastic, right? So it is B. 21. Young's modulus is defined as the ratio of, and that is giving us the longitudinal stress and the longitudinal strain. So E is giving us stress on what? Strain. That is the longitudinal stress and strain. 22. The unit of Young's modulus is, so here we can derive the unit and it is giving us, it is mostly in what? Pascal, which is Newton per what? Meter square. So that means we have it as D, kilogram per centimeter square. Are we okay? Alright. 23. If equal and opposite forces applied to a body tend to elongate it, the stress so produced is called. So we have a body and two opposite forces try to elongate it. What stress is developed here? It is called tensile stress. The material will be in what? Tension, right? So it is tensile stress. Now, 24. A rod is 3 meters long and has a cross section of 400 millimeters square. Determine the force in kilonewton required to stretch the rod by that. We should take Young's modulo of the steel to be that. Are we okay? So here we can derive the force from this formula. We are going to see that we have some parameters given. We have area, length, and other parameters. So elongation produced is the force times the length on area multiplying what? The Young modulus. But before we get the elongation produced, we can say the strain. We can use the strain to find the elongation produced. So strain is giving us elongation on what? The length. Or we can also use the formula stress is proportional or equal to E on what? That. And we can use all parameters given to solve for our parameters. So here even the stretch is given. The stretch, which is the elongation, is given. So from this first formula we can make the force the subject, that our F is going to be the elongation area E on what? L. And when you put it in, we are going to get 80 kilonewton for that. 25. Modulus of rigidity is defined as the ratio of, and that is the ratio of shear stress to shear strain. So this is from normal stress. When we come to shear, we have the shear is also equal to G on what? That. Where this is the shear strain and the shear stress. So the modulus of rigidity is G. So G is going to be the ratio of the shear stress to the shear strain. Are we okay? Now 26. Deformation per unit length in the direction of force is known as deformation per unit length in the direction of force is known as, and that is known as linear strain. Are we okay? Now 27. The unit of force in SI unit is Newton. I think we know this, so that is Newton. The unit of work or energy in SI unit, energy is measured in what? That is Joule. So that is E. Now 29. Hooke's law holds good up to, so when you have the tensile test diagram, which goes this way, something, and it goes, and maybe it comes down. From this diagram, Hooke's law is working at the proportional point. Hooke's law only holds at the proportional point. Are we okay? So we have number 30. If the radius of a wire stretched by a load is doubled, then Young modulus, which is the E, remember we have stress is equal to E and what? Strain. So this E, if the radius of a wire is stretched by a load is doubled, the E will, and the answer is the E will not be affected because this E does not depend on the diameter of what is the load or the wire. It is just a property of the material and it remains constant, so it will remain unaffected. All right, so if you take a 10 mm diameter, it has the same Young modulus as 1 mm, 2 mm. It is just the property of the material. 31. Tensile strength of a material is obtained by dividing the maximum load during the test by, and that is going to be the original cross-section area. 32. Which of the following has no units? And from this, we are going to say it is deflection per unit length, which is what? Strain. Deflection per unit length. It has no units. The value of Poisson's ratio for steel is between, and we have Poisson's ratio is between 0 for steel is between 0.25 to 0.35. That is for steel. Now 34. In an experiment to determine the coefficient of linear expansion of copper, a rod of metal of length 4 mm is found to expand by this when heated from 16 to 100. Determine the coefficient of linear expansivity. So here we have the formula. Final length, if it is being expanded by heat, should be equal to, now we have the initial length. Are we okay? The initial length L plus, let's take 1 plus change in temperature. So L is multiplying that. We have it as this form. So here we are interested in finding what? The coefficient of expansion, which is that we have the final length, because the length is given here as 4. So, and it is going to expand by this amount. So we have to convert the final length to be, that's 4,000 millimeters plus the expansion, which is 0.56 mm, should be equal to the normal length L, which is also plus, or this is multiplication. So 1 plus alpha, changing to that is 100 minus 16, right? And we are going to get 84. When we make this the subject from the expression, we are going to have the expansion coefficient to be that. Very good. Now, 35. A specimen of steel of diameter 10 mm is subjected to a tensile load of 9 kN, which causes a length of 100 to increase to that. Calculate the lateral strain of the rod if the Poisson's ratio for steel is 0.3. So we are to calculate for the Poisson's ratio. Now we know that Poisson's ratio V is the lateral strain to the axial strain, right? So from the problem, we are going to get the axial strain to be equal to, that's the axial on X, will be equal to change in length over original length, and the increase was 0.55 to the original length 100, right? That is 100. So from here we are going to get this as an X value. So we can bring it in and say Poisson's ratio is given as 0.3 multiplying the value we got here should be equal to the lateral strain. And when you do that, your lateral strain is going to be C as your correct answer. If a material expands freely due to heating, it will develop, there will be no stress in the material. Are we okay? When you leave a material to expand under heat, there will be no stress induced in the material. Now, 37. Which of the following can have both negative and positive values? And that is going to be the center of what? Gravity. Are we okay? 38. Determine the moment of inertia through the vertical centroidal axis of a rectangle with base of that and height of that. So when we have a rectangle and we want to determine the moment of inertia, first we can find it with respect to the x-axis and with respect to what? The y-axis. And the moment of inertia with respect to the x-axis is going to be bh on what? On 12. And if we want to do by the y-axis, we are going to interchange that. That is going to be hbq on 12. And that is going to give us, from here we have the base to be 120, the height to be that. So that is height of 100 multiplying a base of 120 cube on 12. And that is going to give us the answer B. 39. Determine the power that can be transmitted by a shaft rotating with a speed of 220 rpm and a torque of this mm. So first we have the N. We know that the power transmitted is going to be the torque omega or 2 pi n on what? 60. And our power is going to be 2, so there's a T here, that's the torque. 2 pi n, n is 220. And the torque, remember, we are working in standard units. So instead of using Newton millimeter, we can convert it to Newton what? Meter. And that is going to be 120, right? So 120 divided by 60. And we are going to get our power to be that. And the 40 is strain is defined as, we know that strain is defined as the change in length to the original length. change in length to original length, and that is strength. So B for us. Alright, so this is all for these 40 MCQs. In the next episode, we are going to solve more of the MCQs. So please subscribe to the channel and see you in the next episode.